Alright guys, welcome to solving radical equations. And what you have to understand today is the process of solving radical equations may lead to extraneous solutions, and we'll talk about that later. And that's usually when you have a variable on both sides. The second thing is you can solve these radical equations by isolating the radicand or the exponent and raising each side either to the power of the index or the reciprocal of the exponent. So just like before, isolate the radical or isolate the exponential and get this alone. How to do that is either you raise each side to the index or raise each side to the reciprocal, the exponent, depending on the equation I give you. For example here, this first one we're seeing we have a radical. What is the solution of this function? Okay? So it's always important with these to check your work, okay? Because there could be an extraneous solution. Meaning you find an x and you think it's the answer, and then when you check your work, it gives you the wrong answer. That's what it means to be extraneous. So 3 plus the root 2 minus x, or 2x minus 3 equals 8. The first thing, before you can raise anything to a power, make sure the radical's alone. The 3 is tagging along here, so we're going to subtract 3 from both sides, and you get root 2 x minus 3 equals 5. Well, that's root 2. There's no index written, so it's understood to be 2. So we're going to raise each side to the second power. And that's what I've done here. I actually rewrote this as 1/2 power. The reciprocal of 1/2 is 2. But you can just square that index if you want to, just like this. And you square the 5 too. So you have 2x minus 3 equals 25. So all you're doing now is solving a two-step equation. You add 3 to both sides, divide by 2, and you get x equals 14. You can easily check here. 3 plus root 2 times 14 minus 3, 28 minus 3 under the radical is root 25. Root 25 is 5, plus 3 is 8, so my answer works. And that's the essential understanding. Understanding that you got to isolate your radical or exponential first, and then check your work to make sure you don't have an extraneous solution. Alright, so let's look at another example. Here you're given an exponent. What is the solution to 3 times the quantity, x plus 1, raised to the 2/3 power, and that's equal to 12. Well, you got 3 tagging along with that quantity being raised to the 2/3 power, so divide each side by 3 first, and that's what I've done. Okay? And now I've taken 3 halves, I don't have anything on the same side as my exponent. So now I'm going to take 2/3, and what's the reciprocal 2/3? It's 3 halves. Raise each side to the 3 halves. And so we're going to take a time out here. We have now the absolute value of x plus 1 equals 8. And it's like, wait, there's no absolute value. How does that happen? So let's look at the side note here. When you solve for x raised to the mn equals k, you raise each side to the n over m power. If n or m is even, then x raised to the mn power raised to the n over m power equals the absolute value of x. Now the denominator's even here, so that means we have to write this in absolute value. Okay? If this was 3/5 power and 5/3, you wouldn't be writing absolute value. But because the numerator denominator here on that fraction is even, you're using the absolute value. So when you now we have an absolute value equation, so we write just what we see here, x plus 1 equals 8, and then the other equation is you take the opposite of every term in here, which is negative x minus 1 equals 8. So now we have 2 possible solutions, 7 or negative 9. Just so you know, both answers check out. So the solution to this equation is x equals 7 or x equals negative 9. Be very careful that when you're raising either side to a power or an exponent, if the numerator denominator is positive in that fraction, then you have to use the absolute value. Alright, in our next example, what is the solution of radical 2x plus 1 minus root x equals 1? Now there's no real easy way to do this, okay? You're gonna have to do some expansion here. And so what I've done first is I've just added root x to both sides. And so then I was left with root 2x plus 1 equals root x plus 1. Then I raised each side to the second power. I get rid of my radical here, but then I actually have to multiply this out using the box method, and I'm left with negative x plus 2 root x. Now this one's a little tough because now I bring the 2x plus 1 over here, and that's where you get the negative x plus 2 root x. Okay, and then I square both sides, and I'm left with x squared equals 4x, and then I can factor out that x here, and I get x times the quantity x minus 4. So my two solutions are x equals 0 or x equals 4. Okay, both solutions are 2. I check my work. Okay, and we can go from there in this. Okay, so all right, so what is the solution of this next example? Now here's where you're going to see an extraneous solution. You've got variables on both sides, and you've got a radical here, and then you just got x here. So again, I'm going to add 5 to both sides first, and then I've got my radical by itself, and then I'll square that radical to both sides. So I'm left with x plus 7 equals x squared plus 10x plus 25. Okay? And now it's a matter of bringing the x plus 7 over. That's why you see the 0 here. And I have this quadratic, which you can factor. Two numbers that multiply to be 18 and add to be 9 are 6 and 3. So my potential zeros are x equals negative 3 or x equals negative 6. So what I want to show you is that if I actually check my answer here, and if I plug negative 6 in, I get a statement that's not true. So negative 6 actually does not work. That's the extraneous solution. I did all my math correctly, and then I substitute my answer back in to see if it works, and it doesn't. So the only answer to this is x equals negative 3. Okay, so if you have any questions or comments, type them below, or you can email me at nicholas.bennett@dc.gov.